Okay, everybody, I think we can start. My name is Lorenzo Vecchi. I hope you hear me fine. I belong to SecurityGen Presents Department, and welcome to this new episode of the SecurityGen series on security topics. Today, we will talk about 5G security, offering a few key perspectives on this topic. Let me anticipate that during the webinar, we will also ask you to participate in two very simple polls. On your platform, you will see a pop-up asking you to provide your preference on a couple of very easy questions. Okay, perspectives. Why this title, first of all? Because let's start by having a look at the 5G ecosystem, which of course we define, I think you all agree, a crowded ecosystem. We have many participants, and it's always difficult to provide a meaningful classification into different groups. But anyway, I tried, for the sake of triggering a useful discussion, I tried to classify most of the entities or bodies or companies involved in 5G into three large groups. Let me start from the group in the center here, the core players. Here, of course, we have the telcos and all the technology vendors of all kinds of functions or even terminals. All of them, of course, contribute, or most of them contribute to 3GPP. Of course, the main body, the body defining what 5G is. There are also other associations like GSMA, but when we look at 3GPP, security is grouped, I mean, the recommendations about security are grouped under a series which is series 33. And the master specification of 5G security is 33.501. Well, but we also have other players offering different perspectives, like enablers and users. Here we find very different entities. In example, we can find the initiatives defining the underpinning technologies for 5G, like the Cloud Native Computing Foundation. We know that 5G network functions are meant to be cloud native, so some perspectives about cybersecurity come also from these bodies. Also, we have users. Let's think about all the vehicular applications, vehicular use cases, V2X. And we have a 5G Automotive Association. And of course, each industrial vertical, 4.0, 5G AA, all the ones you can think about, will have their own perspective and point of view requirements on cybersecurity. Then let's jump to the right-hand side of the picture. We have authorities, public agencies, sometimes open source initiatives. I mean, in every country, there is a national authority about cybersecurity. In the United States, we have NIST. In the United Kingdom, you will find another one. In European Union, we also have a supranational entity, ENISA, the European Union Agency for Cybersecurity, in charge of coordinating and defining policies to be transferred and applied by the different countries of the EU. Then there are also open source initiatives trying to give a perspective on cybersecurity topics like MITRE. I recently launched the FIGHT initiatives. FI stands for 5G, and it's their own initiative to collect and define a threat modeling for 5G, in example. Well, it would take, several weeks probably to talk about the perspectives of all these entities. So today we would like to focus on three very distinctive perspectives. First of all, the perspective of 3GPP, okay? Then the perspective of ENISA as well. So why these two? Because we will start from talking about technologies and how 3GPP worked to make 5G secure by design, as we used to say in the industry. And then we will have a look at a completely different perspective, one of ENISA, of an authority, which must consider not only technologies, but also all the ecosystem and the activities around the technology. And of course, we will close the presentation talking about SecurityGen, our own perspective. Well, let's start talking about the perspective coming from standards. And we will talk about 3GPP and the security foundations embedded in the 5G specifications, first of all. Well, let's have a look at all the new things that we find in 5G. Let's start, first of all, from the radio link. And let's have a look at the generations evolving from 2G to 5G. Okay, first of all, of course, encryption algorithms and ciphering improved, because we started with 64 bits and pretty weak algorithms. And then now we have all 128-bit algorithms, which are much more difficult to break. Okay, but also the architecture of the radio changed. Initially, we had the user equipment able to talk only to the BTS. And from the beginning, user plane and control plane were ciphered. I mean, the GSM specified ciphering for controlling user plane. Then, of course, with, jumping to 4G, we saw also the introduction of the non-access threatened signaling, and the introduction of also the integrity protection for NAS, both ciphering and integrity protection. For radio resource control, ciphering and integrity, introduced already in 3G, and for user plane only ciphering. 5G completed the picture, because now we have encryption and integrity protection for all the signaling between the user equipment and the network, be it NAS, non-access threatened, but also for everything that concerns the radio layer itself and the radio entrance to the network. So radio resource control and user plane, both encrypted and protected, integrity protected. Now, let's have a look at some other news coming from 3GPP. In example, authentication keys and functions. 3GPP created a more structured key distribution and definition, and also defined a new special function for permanent secrets, with the goal of making the breach of secrets more and more difficult. Let me start with what I think is the key new item coming from 5G. I mean, in previous generation, at least for the beginning of radio transactions, the user identifier was sent in clear, like the IMSI example. Well, this is changed here because 5G introduced the concept of SUSI, which is a concealed identifier. So basically, the user equipment never sends its real identifier to the network, and just encrypting it with a home network public key. Well, in the initial authentication phases for the subscriber, basically the SUSI is sent to the home PLMN, where then, if the authentication is successful, then the SUSI is concealed and the serving network can know, finally, the real identity of the subscriber. And this is the SUPI. So the SUSI is converted into the SUPI, the permanent identifier, just after successful authentication, and nothing is transparent on the radio layer. This makes the identification of the subscriber and spoofing of subscriber identity acting on radio layer more and more difficult, if not impossible. Also, 3GPP defines a specific function for the concealment, which is the SIDF, which must be particularly protected. Also defines another function, is a high security repository for long-term secrets like keys. In example, we know that in NFV implementations, some particular processing or information should be managed inside protected enclaves of infrastructure, which are not easily accessible by other virtual machines. And this could be the case for the EARPF, in example, or even for the implementation of a SIDF. So 3GPP also suggests to give particular protection, also in hardware or in the infrastructure, to functions which are particularly delicate or having to do with long-term secrets, in example. Then there is also there are also other news related to keys, the definition of an anchoring function for the serving network, the key CIF. You see here all the keys for integrity protection and encryption, for non-access threat, these two keys, for radio resource control, for user plane. So all of them appear here. And making basically, with this added complexity, it's more difficult to break in and to basically to pose as an authorized subscriber, because it's more difficult for an attacker to get all the keys to be properly identified in the network. Let's also see another key item introduced in 5G by 3GPP. Well, the final decision in home network for what concerns authentication, because in previous generation, basically, the final acceptance of the network of a subscriber, the final authentication of a subscriber was delegated to the serving network, while here signaling and the check of results of calculation based on keys is sent back to the home network, the authentication function in the home network. Here we have the REST star verification, and only after this step, the user equipment is authenticated. And as you see, only after this step, the permanent identifier of the subscriber, like the IMSI, is sent back to the serving network, not before. Let's go on. For network, here again, many important news. Let's start from what happens inside the service-based interface, the signaling bus on which the network functions talk. Well, we know that 3GPP introduces or recommends the introduction of transport layer security, TLS, which basically enables allows the encryption of the communication between network functions. On top, it also allows the use of the OAuth 2.0 framework, so a mechanism for authorizing communications between network functions with tokens and central authority for allowing communication, which could be based on NRF or SCP as well, depending on implementations. These two network functions become particularly important in this case, because they can become the central authorities for allowing communications, authorized communications among network functions. Then we have introduction of the SEP as well, the proxy network function for protecting signaling at roaming borders. You see the M32 is the roaming interface. This is a reverse non-transparent proxy for network functions, provides mutual authentication and integrity protection. Also, the negotiation key management of a cipher suite. And also something more has been introduced at user plane level, because basically with user plane security, 3GPP is defining also some security features for the N9, the interface between user plane functions, allowing to or enabling, let me say, forwarding of GTPU packets only if they belong to active PDU sessions and are not malformed. So this allows to put under control some risks which are related, in example, to spoofing tunnel endpoint identifiers and using traffic pipes, traffic tunnels, even though sessions have not been created. This is a kind of weakness that we have in GTP implementations. Let's go on. Let's talk about the interface for roaming, M32, because 3GPP introduced PRINCE, acronym standing for Protocol for M32 Interconnect Security. As we know, the SEPs acting as proxies have, first of all, have to set up a connection for recognizing each other, let me say, and this is done at a sort of control plane level with M32C interface. And then when we have roaming signal related to roaming, this is exchanged under the N32F logic interface. But let's have a look at the other features introduced by Prince. I mean, consider that some data could be sensitive when transmitted in clear way, like the permanent identifier, authentication of subscribers, authentication vectors, and other. PreGPP decided to adopt the JSON Web Encryption, AWE, which enables to use symmetric key encryption and to encrypt some sections of the signaling message so that nobody can get the services. In this case, how to make sure that nobody, no malicious or fraudster or hacker, let me call it IPX, is introduced the fields to the modification of the JSON content of the signaling messages. So in this case, the SEP, knowing the public key, can verify that the modification has been done by an authorized IPX, and it's not the act of an hacker. Let's go on with this review of the key news. Okay, let's talk about private 5G networks. In example, the latest release, I think from release 16, but anyway, yeah, this is one of the most recent introduction. PreGPP introduced the concept, the network function called NSSAAF, which is network slice specific and SNPN authentication and authorization function, which is a mediator between the authentication mechanism happening inside the 5G framework and some possible authentication frameworks implemented, in example, in a AAA server hosted by a third party or a private network. This enables specific authentication schemes for private 5G. In example, checking the binding between a user equipment identifier and a SIM identifier. This could be important, in example, in industrial scenarios, because you don't want that if you have a sensor, 5G sensor, someone goes there and replaces a physical SIM, or someone introduces, in example, an unauthorized sensor in the network, hacking an industrial process. And so the NSSAF is specifically introduced to allow also reauthentication or reauthorization, slice specific, when a private user wants to apply further authentication or security rules related to subscribers or user equipment identity. Well, and let's go on with some other aspects. Well, also it's important to consider that inside the 33 series, we find the SCAS, security assurance specifications, which are specifications, network function specific specs, aiming at giving recommendations about security. Usually inside each SCAS, you will find two sections, a section which is network function specific. An example, in the SCAS for UDM, you will find that a lot of attention is given to aspects like SUSI concealment. As we said, this is an important aspect, or all procedures related to keys. And then there are also some, inside the SCAS, also some recommendations related to the IT foundations of network functions, which are now common things. So everything that you can do to secure an IT application, that is also applicable to a network function nowadays, given the way this software is developed. So protection of data, operating system features, logging of everything, web server features, if you have a web portal, in example, for a network management, and so on and so forth. And the 33 series include even more, includes also studies, which are not recommendations, and recommendations as well for specific use cases, like V2X use cases, UR-LLC. So it's an interesting reading and gives you the whole 33 series, give you all the technological perspective. Nevertheless, let's consider what can happen. Can we say that 5G is 100% secure? Well, we have to consider the reality, the real life of networks. First of all, signaling could be unencrypted because, first of all, not all technology providers or all operators are ready to encrypt signaling from day one, because you could have not all features could be ready. The operator could not be ready for implementing a key infrastructure. Or if you want to have full visibility of signaling at the very beginning, you might need to work with probes or analytics on signaling, which need that signaling itself is not encrypted. Also, we have some signaling that is not that is vulnerable, and it doesn't belong to the main HTTP2 based framework, which is the PFCP. This is the signaling between the session management and the user plane function. This is vulnerable as well. NRF and SCP are network function having a stake in providing a register or a signaling control point for all network function, and can be critical and can be attacked. Also, an example using OAM entrance. We have APIs which are exposed for the network by the network exposure function, and APIs could be abused. So security by design doesn't mean that when you actually deploy a network, everything will run fine. So before we move to the next session, now I would like to launch a poll. Max, if you help me with that. Let's launch the first poll. Yeah, please, I will ask you to enlarge the screen to see the question well. So what I would like to ask our audience is, what do you think is the best recipe for a secure 5G implementation? I mean, should an MNO just apply all 3GPP security features and forget the rest, so forget intrusion detection systems or traditional penetration tests? Or should an MNO really track the difference between standards and actual implementation, so user pen test and IES? And I see that we start receiving answers. Very interesting. Let's wait another minute or so, and let me say that 80. Okay, the opinions are changing, but now the poll result is stabilizing. Let me say 75% of our audience say that pen test, IDS. Or now it's 70-30. Okay, let's say 70% thinks that measures like pen test or intrusion detection system, these measures, also well known from the IT environment, are still important, while around 30% thinks that using the 3GPP security features from day one could be enough. Well, interesting. Now the percentage is actually 75 and 25. Very interesting. I thank you for these results. And yeah, because in SecurityGen, we think that basically the real life of networks must be taken into account, and it's possible that not all 3GPP security features will be ready from day one in networks. Okay, let's move on. Let's move on. Let me share the results, and yeah, I think now everybody can read. 29% to answer one, just apply 3GPP security features, and 71% votes for using other measures like pen tests, intrusion detection systems, and others. Okay, thank you, everybody, and let's move to the second part of the webinar. Let's talk about the perspective of authorities. We will talk about ENISA. I call it threat modeling the EU style. Again, NIST could have a different perspective. If you consider MITRE with their 5 initiatives about 5G, they will have a different perspective. But let's start from this one. Well, let's see this one. As I said, it's impossible to talk about all points of view in one webinar only. Well, yes, let me say that ENISA publishes mainly 2 documents The first one is the threat landscape for 5G network, which is the threat modeling document. Then we have the second document is a toolbox, something that is designed with the idea of providing measures for more secure 5G networks. And then there are some collaterals regarding an example of the impact of NFV on 5G cybersecurity. But today we will talk about threat modeling and the toolbox. And I would like to guide you through the structure of these documents to make you understand what kind of point of view they present and the useful information that you could extract from them, because these are long readings. An example, the threat modeling document is around or more than 200 pages. So today we will see the main chapters and content. And also we'll do the same with the toolbox document. First of all, let's see it in steps. One of the first key things that you find in the document is the definition of 5G architecture and its components. And you see the components here on the right-hand side of the slide. Of course, you find core network, radio access. Then you find also management and orchestration functions, NFV, network function virtualization function, something having to do with use cases like multi-access edge computing, infrastructure, and also processes. The processes are important. We will see how much emphasis is given to processes by ENISA. And this is the first one, what you find at the beginning of the document, basically. Let's see the next section of the document. Step 2, the definition of vulnerabilities. Well, for each one of the components of a 5G, ENISA defines vulnerabilities. Here I took examples from the core network category, from the RAN category, and from the physical infrastructure category. An example from the core network, vulnerabilities in implementation of AMF security functionalities is a concern. An example, incorrect implementation of mechanism for mobility intra-RAT, because in this intra-RAT radio access type of mobility, you could have hacker able to put their fingers, basically, or procedures related to duty, having to do with identification of the subscriber, or procedures related to authentication and key agreement. Again, this is critical. But beyond technical aspects, let's see the structure. Basically, for each vulnerability, we have a name, of course, a description, so a classification on a name description. Then we have a toolbox measure, referring to the toolbox document, some measures to mitigate this vulnerability, and then a threat category. For each vulnerability, there is also a list of possible threats related to that vulnerability. And the threat categories are introduced later in the document, and we will see it shortly. Well, another very important piece of information that you find in this document, I call it step 3, is the list of assets. This is a really comprehensive, or trying to be comprehensive, effort by ENISA to define what 5G is in terms of assets. And the classification tree starts from a root, which is inside this brown color box. And you see that the network is considered as done by network products. I mean, 5G is done by the network products themselves, fine, MNO, but you also find interconnections and protocols. And here at SecurityGen, we have something to say, and we'll talk about it later. But you also have processes and organization. So assets are not only the routers, the antennas, the node Bs, the servers with network functions, no, also organization and processes. And when it comes to network products, let's see a few examples. When it comes to network products, well, the list of assets is very easy to understand for people working on networks. You will find an example of the 5G core and RAM functions. You will find all networking elements, Ethernet switches, microwave, fiber optics, whatever, physical infrastructure of the data centers, storage, servers. You will find also logical entities like management plane, control plane, user plane, virtualization infrastructure, virtual machines or containers, and so on and so forth. This is the technology. But when it comes to management and orchestration, we find NFV orchestration, the virtual network function managers, the network slicing management, all things still on the technological side of the perspective having to do with the network. Now, let's see some examples. Important in example processes. So basically, the network design, the build phase, the operation phase, even enterprise risk management phase are assets, are considered assets together with security assurance processes. Just this is really peculiar, and of the ENISA approach, at least this is made, it's not completely new, but it's made explicit as far as the relationship with 5G is concerned. Then we have also services. Interesting to say that ENISA mentions EMBB, enhanced mobile broadband, or massive machine type communication, or ultra reliable low latency communication as use cases, together with the V2X applications. And we have MEC also considered as an application. So assets is something that I would suggest our audience to read. Then let's go on and let's talk about the taxonomy of the threats. Again, we have talked about vulnerabilities. We haven't talked yet about, or ENISA, I haven't presented you the way ENISA classifies threats. There are basically around 8 or 9 classes. And let's start from the most critical ones when it comes to cyber attacks. The first one is called NAAA, and it's nefarious activity or abuse. The second one is about eavesdropping, interception, and hijacking, called EIH for short. In the first class, NAAA, we find all the main bad actions that hackers could do to an asset: denial of service, introduction of malicious code or software viruses, abuse of authentication, data breach, intrusion, frauds, spectrum sensing when it's about radio networks. Threat to signaling, it's in red because it's where we at SecurityGen have something to say, and I'll show you later. In the eavesdropping, interception, hijacking class, we found espionage activities, traffic sniffing, man in the middle to hijack sessions, and so on and so forth. I mean, trying to steal the content of the communication. Then we have physical attacks, but also let's see. We will see that in the threat taxonomy, we don't have only events related to bad intentions or to attacks by hackers. We have also threats coming from unintentional damages, failures, outages, disaster. So this is another important, important aspect of the ENISA story, let me say, because considering the perspective of an authority, you must consider that 5G is considered as part of a national critical infrastructure. So it must be well done, well designed, secured, and resilient, also not only in case of attacks by hackers, but also in case of disaster, unintentional situations of any kind, because basically an authority will consider that 5G will be a part of a national critical infrastructure, especially if we consider the new use cases like vehicular applications, industrial campuses, and so on. Well, putting it all together, let's continue to see the structure of this document, because later on in the document, you will find a threat to asset mapping. So this time the perspective is some way reversed compared to the previous chapter on vulnerabilities, because here you will find for each one of the threats under each class, in example, under the nefarious activity abuse of assets, we will find the definition of some typical threats. In example, manipulation of network configuration and data forging, exploitation of software or hardware vulnerabilities. So basically, all the items that we saw listed here under each category is taken back and is mapped towards the assets which could be affected by this threat. In example, here for manipulation of network configuration and data forging as the SDN, NFV, manual, and others. And also potential impact is declared, like information integrity, destruction or service unavailability when it comes to manipulation of network configuration of data. Of course, you might have some slightly different points, opinion on this classification. An example, when it comes to manipulation of network configuration, I would also introduce core network here, not only RAN, an example. But anyway, this gives you at least a good list of checkpoints to consider when you want to understand which assets could be affected by each threat. Again, towards the end of this document, you will find the long appendix section. This is the long section where you have a more detailed analysis considering one appendix per each 5G component. Again, we go towards the 5G components. Vulnerability description is expanded together with security requirement and control and some other info. In example, going back to the big category of core network that we saw at the beginning here, in step 1, all these items here. Well, yes, for each one of the items inside the core network, for example, here the UDM, we have again a description of a vulnerability. We have security requirements related to the mitigation of such vulnerability. In example, here, something related to the concealment of a concealed identifier into the public identifier. In example, the algorithm used for subscriber privacy shall be executed in the secure environment of the UDM. As you said at the beginning, some particular function should be not executed in the general purpose telco cloud, but in some protected hardware and clouds. This could be a thing. Okay, and let's have a look at the second document, key document that ENISA publishes regarding this topic. And basically inside the toolbox, first of all, you will find the definition, high-level definition. Let me say it's a high-level definition of risks, together with mitigating measures and supporting actions. So risk may be mitigated by measures assisted by supporting actions. This is the philosophy. When it comes to risks, basically we have 5 classes. They are very broad classes, as you say, from risks coming from insufficient security measures to risks related to the 5G supply chain. And this is very peculiar, risks related to end user devices. Let me stop here, 5G supply chain beyond threat actors, because we know that with 5G, with opening up, with something that already happened with NFV, I mean, an open ecosystem of technologies, not anymore closed network functions or nodes provided by a single vendor, the stability and the reliability, the trustworthy, also the trust that you can put on a supplier have become really, really important. And the supply chain is a critical element, is a factor of risk, if not properly managed. And inside these 5 classes, then we have a breakdown in 9 big classes, like R1, misconfiguration networks, lack of access control, very basic risk classification, for example. Well, when it comes to the measures to mitigate such risks, they are classified in technical measures, easy to understand, and strategic measures, having to do with, again, the management of third-party suppliers, the diversification of suppliers, everything having to do with a stable and reliable supply chain, regulatory powers. So there is a lot of politics inside this kind of perspective. It's not anymore only technology. Let's have a look at these measures in a couple of slides. When it's about the technical measures, but you can see them on the left-hand side of the screen, from TM01 to TM10. TM01 really easy, ensuring the application of baseline security requirements. So apply everything, every recommendation related to security. Ensuring strict access control okay, it's normal in an IT infrastructure of any kind, or IT environment or application environment of any kind. Reinforcing software integrity, update, and patch management. Patch things correctly and on time, especially if you have known vulnerabilities. And let's have a look on the right-hand side, the strategic measures. There is, again, as I said before, a lot of emphasis given to supply chain trust, supply chain diversity, increasing the power of authorities. SM04, in example, control the use of MSPs and equipment suppliers for line support. So make sure, in example, that who gives your services or provides support to your 5G network is a reliable partner, has security policy. So it goes inside policies, not only inside of technologies like encrypt the data, okay? It's very important as M02 because it's something where we work at SecurityGen. It's about performing audits on operators and requiring info. Auditing is something that we recommend as well. It's part of our core business. Strategic measures, let's close this section with this part, are about, again, a lot about political measures. Like SA02 is reinforcing testing and auditing capabilities at national and EU level. SA03 is supporting and shaping 5G standardization. Developing guidance on the implementation of security measures in existing 5G standards. So all these supporting actions are about influencing also the development of the technologies to make them more secure. Influencing national policies to make sure that these critical infrastructure are well protected and resilient and bulletproof, let me say. And every nation, probably in every country, you can find this kind of perspective. But of course, in European Union, this is sort of harmonized and coordinated at this upper layer by ENISA. Well, I don't want to spend too long on these examples because now I would like to go on and provide our perspective, the SecurityGen perspective. Let's start from some things that ENISA says and on which we at SecurityGen agree. First of all, roaming. Okay. In the document of ENISA, it's clearly written that diameter and SS7, so protocols using 2, 3G and 4G generations, will stay for a long time. 5G standalone networks will take a while to take off. 5G roaming based on HTTP2 and SCPP will take a while. And so a previous style of roaming will stay for a long time. So it's important that also these legacy protocols are part of a security framework for 5G, because these protocols will be used also by 5G NSA and for interworking with 5G. Then ENISA says that interconnections and protocol assets, in example of interconnections, roaming interconnections between home and visitor PLMNs, also SS7 and diameter protocols. And here we agree, and here it's where we provide services and solutions. Also, ENISA says that the service-based interface, the bus, the signaling bus, where the 5G core components talk, needs to be secured. And improper implementations here are expose MNOs to threats, and we agree basically. So what are we doing to make sure that our customers are protected when it comes to these aspects? First of all, let's talk about our solution quickly. Our approach, which is the philosophy behind the solutions that we create, is the IDP approach: inspection, detection, and protection. We think that networks must be audited and inspected as an hacker would do, using the same attack methods that an hacker would use. And for this purpose, we provide a breach and attack simulation platform, which is called ACE, which is the artificial cybersecurity expert, which is a signaling, breach, and attack simulation platform. When it comes to go inside the networks and protect them, we think that an intrusion detection system is key, together with a firewall. TSG is Telecom Security Guard, is the commercial name of our solution, combining IDS and firewall. You can purchase them separately, but combined if you like as well. IDS logs everything that enters into a signaling network. Firewall, well, we all know a firewall is able to filter out things. Let's see how these items, these solutions work in networks. Let's consider core network assets connected to an IPX for roaming purposes. Well, hackers using roaming interfaces as an attack vector might enter at IPX level, but more often they will use a compromised MNO to launch attacks using the IPX as a vector and attacking all generations, 2G, 3G, 4G, 5G. Well, we know that 5G roaming is not a reality yet, but our solutions are getting ready also for HTTP2 signaling. Let's start to see ACE. ACE is the breach and attack simulation. So as inside the largest DB of attack methods, really more than 200 considering all the protocols, well, these attack methods allows you to create automatically in a very easy drag and drop way inspection plans for all generations, and you can use it to inspect the robustness from security point of view of your roaming countermeasures entrance of a network, like your signaling firewalls, if it can be bypassed or not, measures applied at STPs or DAs level, an example, configurations or whatever. So ACE will simulate an hacker and would do whatever the hacker is able to do. Of course, ACE is very interesting because it provides you automatically generated reports of vulnerabilities and recommendations, very useful for a security SIEM. Now let's jump inside the network and let's consider the TSG solution. TSG is backed by the largest DB of attack signatures. When it comes to the IDS, IDS needs only to get a mirrored copy of the roaming traffic, so a passive copy done with port mirroring, and it matches this signaling traffic with this DB of attack signatures and lets you know if an attack is going on or not. So it provides you full visibility. Full visibility, it's like logging everything that happens on signaling protocols on roaming interfaces. Complete logging. This is a recommendation also applied by cloud providers in the IT world. Finally, firewall enables you to filter out attacks. The firewall and the IDS are backed by the same database, so whatever the IDS can identify, you can create a rule to kick out that particularly dangerous situation. Well, let's have a look at the service-based interface now. This is something that we've done in Far East with one of the pioneers of 5G. They called us because, of course, they recognize that 5G roaming is not going to be a reality soon. But they asked, let me understand if the implementation of my 5G core network has weaknesses from inside. And we performed a study and implemented methods of attack against the 5G network functions from inside the network, the service-based interface. In example, an attacker could pose as a network function and register itself inside the NRF, and this way potentially overriding, removing, or replacing a real instance and creating damage or stealing data or compromising the normal operations and services of 5G functions. So what did we do for in practice for this customer? Well, recognizing that the M32 interface is not going to be used anytime soon, well, we developed through our ACE, the Artificial Cybersecurity Expert Platform, a breach and attack simulation, a set of methods, HTTP2 methods, for probing the reaction of a network functions from considering an insider, an attacker, an hacker, acting from inside the service-based interface. So we've been able then to provide recommendations on how to make the reactions of the network functions more robust to avoid insider attacks. This is part of our vision for 5G networks, especially in the early stages. Let's look at again at something related to our vision for the future. Industrial campus scenarios. We know that for the 5G promised land is about new use cases, bringing new money to MNOs, like industrial campuses, smart factories, smart ports, smart mines. They could be served by standalone non-private networks or by network slices. But in any case, in these situations, risks are not acceptable, and cybersecurity attacks can become a problem for the human health, for safety. But before going on describing our vision for these scenarios, I would like to launch the second poll for today, and I would ask Max to assist me to bring it on screen. Yes, I would like to have your opinion. How much do you think the enterprise customer, business customers, are willing to pay MNOs for private 5G security? As much as needed or the bare minimum? I mean, are the final customers, enterprise customers, willing to pay for security, or their approach is to try to save on this aspect? What's your point of view? Let's give our audience one more minute. Okay. Answers are coming. I think that we can, okay, some more votes are coming in. Percentages are changing. I think that we can stop and share. Okay, interesting is that basically 64%, 2/3 think that final enterprise customers want to save money on security, while others think that they would spend as much as needed. Okay, this is very interesting. I really thank you, because this gives me the pulse of the industry. Okay, let me go on now with the last two slides. Let's have a look at what we think anyway. Some measures could be introduced to for private 5G use cases. Use case one, let's consider a fully private 5G based on standalone non-public network implementation. In this case, you have a 5G network functions supported by a kind of NFV infrastructure based on VMs or containers. No, doesn't make any difference. And then we have a private campus, the private data center with industrial applications, F1, 2, and N, and possibly a way out to the internet as well. Well, what we think is that anyway, even in this case, even if the network is completely isolated, in order to make sure that no attacks are injected, attacks against the 5G network functions are injected from the other private DC functionalities, entities, or from the NFV itself, it's important to introduce at least the intrusion detection function inside the service-based interface. It's important to log at least all signaling events, to match them with a database of attack signatures, to make sure that nobody from any access is injecting attacks against the network functions. Otherwise, the operations of an industrial plant, an example, could be compromised. But let's have a look at the use case two, again, about private 5G. And this is the final slide. Also, when we talk about network slices, so with a very ugly acronym, public network integrated non-public networks. In this case, the operator, the MNO, provides the network slice to its customer, also for an industrial campus, in example. And there are some common network functions and some network functions which are specific to the slice. Well, in this case, as you see, we have an implicit interface on the service-based interface between the network functions of the slice and the common network functions. What we think is that it's important to introduce some kind of protection measures at this level. In example, the MNO could introduce an intrusion detection system and a signaling firewall at the entrance of the common network functions to make sure that no attacks are injected from slices, which could compromise an entire to be piece of network of an MNO. And this is the reason for having visibility given by IDS and firewall at the entrance of the SBI on the common network function side. But the other way around, the MNO, if a final customer is willing to pay, could sell security as a service also for the 5G slice by introducing an IDS and the firewall at the entrance of the SBI on the slice side here, to make sure that it's not possible to inject signaling attacks from, for example, other slices, other entities, or whatever else, whoever else, inside the network slice. So in this case, the IDS and firewall are inserted inside the slice. Well, this is the last slide. I thank you. So we took 1 hour, basically, as we planned, even if we started a few minutes late. Now we are open to possible questions, or yeah, we still have 5 minutes. So if you want to launch a few questions in the chat, we are open to reply, to provide our point of view, an example. And yeah, we still have a few minutes. Okay, we have something in the chat. Okay, it's Max. Let's stay on and over a couple of minutes anyway. We are available. Okay, I see that some of our guests start leaving the room. I see no incoming questions. So let me thank you for the time you dedicated to us. I hope that our webinar was useful for you, gave you useful information. As I said, I wanted to provide you guidance on the technological point of view and on the point of view of an authority, also giving you sort of recommendations on how to read some of these tough documents. Sometimes they are long to read. Hopefully now you know better the contents, example, the ENISA perspective, and you can use it. And okay, we have one question. Okay, about the presentation, I will have Max will reply. Yes, sure. Okay. And Max provided a reply. Yes, we will send the presentation, of course. So again, many thanks. And this is not our last webinar, of course. We have a series, as we said. We have regular webinars, sometimes dedicated to a region as of today, as it was today, sometimes for a global audience. So we invite you to follow SecurityGen on our channels, on LinkedIn, an example, so that you can stay up to date. You can know about our next events. I see that Max also shared our website. Again, I thank you all, and see you at our next webinar. Thank you very much, and have a nice day.